First, I have to identify what type of equation this is. And then we're asked to solve for s. This is a 5, this is little h, and this is pi, which is a number, and this is r. So you can say, r is a variable, s is a variable, h is a variable. True. However, we're specifically told to solve for s. S is under the square root. So I'm going to ask myself, what type of equation is this? I know so many now. First of all, a binomial is not an equation. Maybe you wanted to think about polynomial. So one more time, what type of equation that is? Just read it. Not out loud, just read the equation. And when you read the equation, you'll say, of course I know what it is. Of course, it's a radical equation, right? It has a square root in it. Good. So how do we solve a radical equation?
Do r to the 1/2?
No.
Opposite, you square both sides.
I square both sides. Good. So the left-hand side is r squared, and the right-hand side is 5s over pi h. I'm solving for s. What do I need to do to both sides? I need to remove this. So I'm going to multiply by the multiplicative inverse to do it in one step. But you don't have to do it in one step if you choose not to. I choose to eliminate both, I should say all three at the same time. 5 will cancel 5, pi will cancel pi, h will cancel h. So that's our s. Pi h r squared over 5. Very good. Good question. Anything else? Anything else? Anything else that you worked on?
I have a question on 17.
From the same. On 17.
1.617.
It's not open. So I don't know why. Okay. So the absolute value equation?
It was 8x 2 over 3.
8x raised to the power 2/3? Okay.
Minus 71x 1 to the 3rd minus 9 equals 0.
Perfect. Perfect example. Let's take a look and decide what type of equation this is.
What number was that?
I'm not sure.
I think it's like 15. 15.
And section still 1.6. Good. So let's look at the equation and decide what this is. What do you think?
Rational exponents.
Very good. Awesome. However, I am going to be in trouble with it. So I'm hoping for something else. I'm hoping for, because remember, very good point. Let's go back because this is important. So when we looked at rational equations with rational exponents, how many terms, if you want, if I can say that, had a rational exponent? How many? This is 1, 1 to 3 halves. Just one quantity to 3 halves. The next one had 1 quantity to 5/3. Okay? And this one has 2 quantities with fractional exponents. It's not going to be easy unless The equation is qua in. That's my hope. And if that's the case, I'm going to say let x to 1/3, let's say, to be whatever letter you want. Okay, I don't know what you said, but I heard y. Is that y okay?
That's fine.
Okay. But it works only if this quantity turns out to be, that's it. But is it? When I square x to 1/3, do I get x to 2/3? Because if you say no, then this is not y squared. Copy the base, multiply the exponents, and we get 2/3. That's why this is indeed y squared. If I square x to 1/3, I get x to 2/3. So if this is y, this is definitely y squared. So keep that in mind when you see an equation like this with two quantities with fractional exponents. Say, oops, this is too difficult. It should be, and I'm hoping for, quadratic in form. Very good. So then the equation, can anyone dictate now the new equation?
8y squared minus 71y minus 9 equals 0.
Very good. Awesome. That's it. Perfect. So now, if you remember, if factoring, because I'm not asked to factor necessarily, I can use any method I want. If factoring takes more than 20 seconds, forget it. Use the quadratic formula. It will not take too long because the product and the sum are quite clear. But if you want, we can use the quadratic formula, whatever you want. Any suggestions? Let's.
I think factoring is easiest.
Okay, I agree. So I'm looking for two numbers whose product is this, which is negative 72, and whose sum is negative 71. Can anyone give us two numbers whose product is negative 72 and whose sum is negative 71? One of them has to be positive and one negative because the product is negative.
Negative 72 and 1.
Very good. Awesome. Negative 72 and 1. The product is negative 72. The sum is negative 72 and the sum is negative 71. Very good. And then we have to go back and replace the middle coefficient, in the middle term I should say. 8y squared minus 72y plus y minus 9 equals 0. Is this okay? And now I have four terms. If you go back and combine those, we're going to be in trouble. Instead, what are we going to do? Yes. So what would you factor out from the first two? What is left in parentheses? What should I get from the other two before I even look? It has to be there because I found those numbers. I need sign and factor. Very good. Awesome. So then I factor out the greatest common factor, which is perfect. And then I have awesome. So I have two options for y. And you can say, well, who cares about y? No one. We'll go back to x in a minute. So the first y is, and the second y is, we move 1, it becomes negative, and we divide by 8. Now I have to go back to the original equation. And I realize that I have two equations to write. So this is what equation and this is what? Y represents x to 1/3. So then this equation is x to 1/3 equals 9. this equation is, all I have to do is replace y now. I'm going back. So y gets replaced by x to 1/3. And then the second equation, x to 1/3 equals, very good. Now I have to figure out what to do. And this is much easier than the original equation, in which I had two quantities with rational exponents. So what do I do here? I have to raise. I cannot multiply. I have to raise both sides to, very good. So x equals,
279.
so 9 times 9 is 81, 729. And I do the same thing here. So I get x equals, this one is negative, 1 over 64 times 8.
Yeah, 512.
I should go back and check why. Because I raised both sides to a power, but I raised both sides to an odd power. Both solutions will work. Guaranteed. Very good. Very good question. This was not an easy problem at all. Good. Anything else that you would like to go back to? Other questions? Very good questions. Anyone else? Are you keeping up with the work? Will you say it again?
It's wrong. Yeah,
I know.
it is. There's like, I'm struggling to get it done.
So at least do half of it between classes, so you can ask questions and you know, not fall behind, and then can go back and do the other half. So at least make sure that from class to class you have at least half of everything that we covered. Okay? So try to do that, because then you will not fall behind and you'll be informed every class.
Our quiz is on next week, right?
Yes.
Okay.
Yes.
Will we do next week?
What I would like you to work on is what we covered,
Okay.
not what we are in the middle or we didn't finish.
Okay.
Yes. No, those, I'm responsible to present the material first, and then you're responsible to do it at home. I'm not, I'm going to move the dates, of course.
Okay.
Of course.
That's what I'm
Oh, yes, of course. No, absolutely not. If I didn't cover something in class, you're not responsible to do it at home.
Thank you.
No, of course. I will not do that to you. Okay, anything else? Anything else that you worked on? Anything else? Okay, so let's go back where we left off. We are in section 1.7. So the plan for tonight is to finish 1.7 and then go back to one handout on factoring. And then hopefully we can start chapter 8. And we're in chapter 8 with another class. Then we can start chapter 2. Okay, sorry about that. So we looked at only one inequality, and I don't want to forget, you will see in my math lab what is called set builder notation. Set builder notation. So for example, if I have a -1 less than or equal to x less than 3, can anyone give us the interval notation for this? Because it's the equal symbol, it's going to be a bracket, -1, comma, with a, very good, perfect. Now this is the interval notation. However, the set builder notation, and my math lab, I want you to be aware of this because my math lab will ask you, is this. Braces, left and right, x, values of x. This bar, vertical bar, stands for such as, or having the property. Having the property. Such as or having the property. In other words, the solution set is made out of x, values of x, having the property this. So what's the difference between these two? Nothing. So I would not request this from you, but I want you to be aware of this because you will ask you. And it will mark you wrong if you put the interval notation. And sometimes it will ask you the interval notation as a solution. So be aware of the set builder notation. So then I would like to look at another linear inequality. One with fractions we did last time, right? The last one was with fractions, the very last one that we looked at. Okay, so this time let's look at one without fractions. Let's say 50. 6 x minus 1 minus 4 minus x greater than or equal to 7x minus 8. This is a linear inequality. What would you recommend we do? Say it again. Very good. So then 6x minus 6 minus 4 plus x greater than or equal to 7x minus 7x. Any questions? We distributed 6 and we distribute -1. Then combine like terms. Do not start moving terms around before you combine. So 6x plus x is 7x minus 10 greater than or equal to 7x minus 8. Now I would like to keep the variable on the left, so I move 7x and I move 10. But when I move 7x from the right to the left, what do I get?
0.
Very good, thank you. Awesome. Greater than or equal to, when I move -10 to the other side, it becomes positive, and 10 minus 8 is 2. What do you conclude here? I'm telling you having $0 is better than having 2. No. So what do I conclude about the inequality? Thank you. It's false. I got to a false statement, so therefore the inequality has no solutions. Very good. Okay. Let's look at the second type, compound inequalities. Compound inequalities are inequalities that are basically two inequalities in the same boat, so to speak. 58. -6 less than or equal to 1/2 x minus 4 less than -3. As you see, these are two inequalities. This is one, and this is the other. Okay, we're after x. We want to solve for x. Any suggestions on how to start? What do we have to get rid of first?
-4.
Very good. This is what I need to get rid of. So I will have to add 4 to all three sides. -2 less than or equal to 1/2 x less than 1. Awesome. Now what? What do I need to get rid of now? Very good. Multiply everything by 2, so I get -4 less than or equal to x less than 2. In interval notation, this is?
Bracket -4, 2 with parentheses.
Do we all agree with this? Yes, please.
Just a question with concept, like for example, if that was 2x, and you had to divide each side by 2, wouldn't the signs flip?
Only if I divide by -2.
Only if divided.
Right. So let me refresh your memory on that. Is 2 less than 10?
Yes.
What if we decide to divide both sides by -2, and I get -1 and -5? Is -1 still smaller than -5?
No.
No. So this happens every time we multiply or divide both sides of an inequality by a negative number. Multiply or divide both sides by a negative number. We have to switch the inequality symbol. I'm sorry?
It switches when you divide it by a negative.
Or multiply.
Or, okay.
Divide or multiply by a negative number, we have to switch the inequality symbol. Okay, the last type of inequality is number 3 that we are reviewing. Absolute value. Inequalities. Absolute value inequalities. And they are of 2 types. And I am going to present a very simple example, and then we'll move on from there. Okay, so what is the absolute value of a number? What does it represent? If I say the absolute value of 3, you will say 3. The absolute value of 5, you will say 5. The absolute value of 0, you will say 0. The absolute value of -2, you will say 2. What does it represent? Please.
On the x-axis, how many units you are from 0?
The
Because if it's
distance
negative.
from 0. Absolutely, that's all I needed. So the absolute value of a number is the distance between 0 and that number. The absolute value of x is the distance between 0 and x. Awesome, that's all I needed. So then, what does this say to us? Here's what that says to me. It says find the numbers x whose distance from 0 is exactly 3 units. Or less. Exactly 3 units or less. How many numbers have the absolute value 3 units?
3 and -3.
Perfect. And now where will I find those numbers whose distance from 0 is 3 units or less?
-2, -1, and then +1, +2.
So how do I write that? I don't know how to solve this. If I don't know to correctly replace it by what it equals to or is equivalent to. 3 units or less. I have in my pocket anywhere between $5 and $10. How would you write that? It's an unknown amount of money that I have, but I know it's between 3 and 5, or 10 and 20, or
5 less than or equal to x less than or equal to 10.
exactly. So now I'm saying this to you. We are trying to find numbers whose distance from 0 is 3 units or less. How do I write that? Exactly how you just said it.
-3 less than or equal to x.
That's it. That's the answer. 3 units or less. Now, if we represent this on the real line, thank you very much. If we represent this on the real line, then I have -3. I don't care for units. We are just talking about the situation here. This is the solution to this inequality. And in interval notation, this is -3 to 3. Now, the other one says something totally differently, and it cannot include this solution. So let's analyze that one. That one says that now I'm looking for numbers whose distance from 0 is 3 units or more. 3 units or more. I cannot include this. This is already taken by something else. So 3 units or more, please.
Would it be bracket 3?
No, just let's translate it first. Yes. So this has to be translated into 2 separate inequalities. 2 separate inequalities. So one that will represent this territory and one that will represent this territory. We're talking about inequalities.
Okay.
For this one.
Right, x is less than or equal.
For this one.
Oh, x is greater than or equal to 3.
Very good. And now for this one.
X is less less than or equal to -3.
Very good, awesome. So be careful. This one represents this territory. This one represents less than or equal to -3. This inequality is more difficult than the first one, and it will have the solution with a union in between. So now I need to present this territory, union this territory. I'm ready when you are. X in the interval. Very good, comma. Very good with a bracket, awesome.
And then 3 something.
Awesome. So please be aware of these two different types. One that says I'm in between, and the other one that says I'm completely outside. Notice that this one, we are able to present it in a chain and solve at the same time, but this one we're not. One other thing that I want to make sure you understand is that the inequalities, this is not possible. Do not ever write this. This is not possible. Do not ever write this. It's either this or this. This, impossible. Not allowed. This, not allowed. Okay? So do not try to present this like that one. It's not possible. You have to present to the right of 3 or to the left of -3. Keeping this in mind now, let's look at problems and see how much we understood from this. Okay, ladies, please. Okay, let's start with 66. So the absolute value of 3, parentheses, x minus 1, plus 2, less than or equal to 20. And looking at this, you could say, what is this? This is not what you just did. Yes, it is. But I did it in a very simple way with a very simple example, and this is a more sophisticated one. So, of course, I'm going to ask you now, what is the first step? What should be the first step here? Exactly. I have to distribute. So I have 3x minus 3 plus 2 in absolute value less than or equal to 20. What should I do next? Very good, awesome. This is common sense. We haven't done anything yet. This is simple and pure common sense. Now, here is how I read this inequality. I covered it, and I say, I'm looking for numbers whose distance from 0 is 20 or less. 20 or less. Which type is it? Is it the easy type that I can write as a chain? Or is it the difficult one that I cannot write as a chain?
You can write it as a chain.
Yes. One more time. I'm trying to find numbers whose distance from 0 is 20 units or less. That's what this says. 20 units or less. So how do this is it. I cannot do anything here. This cannot be solved unless I change it into something that is equivalent to it. How do I write it? $20 units or less. 20 or less.
-20 less than or equal to 3x minus 1 less than or equal to 5.
Very good. Thank you. That's it. These numbers have to be found between -20 and 20. So then they have the distance from 0 less than 20 units. Perfect. We just solved an example like this. It's a compound inequality. What is the first step?
Add 1.
Very good. -19 less than or equal to 3x less than or equal to 21. I added 1 to all 3 sides. Perfect. Then,
Dividing side by 3.
very good, awesome. So -19 over 3 less than or equal to x less than or equal to 7 or 21 over 3. So now in interval notation, can anyone give us the interval notation for this?
Bracket -19 over 3, comma 7, bracket.
Very good, awesome. So this is indeed the interval notation, negative 19/3, comma 7, and that's it. I don't think we feel better about the absolute value inequalities yet, do we? Not yet. Is it because we don't understand it, we don't remember any of this, or what do you think? You are helping me if you're telling me what I should say more. Yes? You want to say something?
No, I was just gonna say, I think
You,
because of the pattern is changing.
there are only two options. So either this or this. So let's look at another. See how we do on the next one. Let's look at 74. And this is 5x minus 2 in absolute value greater than 13. Again, we have to analyze the situation. We don't know yet. We haven't decided yet which type it is. So let's read it. I'm trying to find these numbers whose distance from 0 is more than 13 units. So the question is very simple, I would say. I should not say it very simple. We only have two options, in between or outside. Is it in between or outside? Right, because it says greater than 13, greater than 13. So then these are two separate inequalities that we have to write and solve. And the final solution will have the union in between. So I'm ready when you are.
That's not as big as greater than 13. And 5x not as big as less than negative 13.
Do we agree with this? So we cannot include anything in between. That is taken by a different inequality. So it's only the outside. Oops. Good. So I have to solve this inequality by adding 2. So this is 5x greater than 15 and divide by 5 greater than 3. I solve the second one, adding negative 2, or I should say adding 2. So 5x less than negative 11, x less than negative 11 fifths. And now please tell me how to write the solution.
The parentheses, negative infinity to negative 11 fifths, parentheses, union, same thing, parentheses, 3 to positive infinity. I asked a question.
Please.
So in the in the stage where you're at say 5x minus 2 and then in the previous problem 3x minus 1, why don't you add 2 to both sides before you go to the process of splitting the inequality down? So like in 3x minus 1, why don't you add 1 to both sides and have it be the absolute value of 3x is less than or equal to 21?
Come on, my turn.
So you're saying, why don't I say the absolute value of 3x, right?
Yeah,
Less than or equal to 21.
yeah.
So that will be 3x less than or equal, greater than or equal to negative 21 and less than or equal to 21. And then I have negative 7 less than or equal to x less than or equal to 7, correct? Okay. So, perfect question. In this answer, you agree that x can be negative 7, correct?
Yes.
So negative 7 is in the solution. I want to check. Okay, so I go back. Negative 7 minus 1. Negative 8. Negative 8 times 3. Negative 24 plus 2. Negative 22 in absolute value. Is 22 less than or equal to 20? No. So here is the reason why we can never do that. This is untouchable. You cannot take anything out, you cannot put anything in, you cannot distribute, you cannot factor, it's not a grouping symbol, you can never touch it. That's what I said. If I don't know how to convert this into this, I will never be able to solve it. So this inequality, I do not know how to solve. I have no way of solving it. But if I know how to convert it into this, then I can solve it. So you cannot touch the absolute value. The same thing here. This is untouchable. You cannot break it. You cannot take anything out. You cannot move anything anywhere. You cannot divide. You cannot multiply. You cannot factor. You cannot distribute. Nothing. This is carved in stone.
You did that in the first one, you could restrict it within it.
Oh, within it I can, because I can have parentheses. I can have any operations inside. But once I got it completely simplified, I can't touch it anymore. Very good question. Thank you. Because, sometimes I may not think of explaining each and every detail because I don't think of it. But that's why you are helping me. I'm learning from you. So I think I mentioned one of my students last Tuesday said to me, asked me a question I would have never, ever thought of saying. And then I thought about, well, she's right. This resembles this. How come they are different? And I explained that to her. Very good. Other questions on this? Do you think we need other examples from any of them or both? I let you choose.
I
Please.
just had a question to
Yes.
clarify. So the union, you always put when it's just greater than or less than, but when it's greater than or equal to, there's no union.
Oh, no, it doesn't matter if I have the equal symbol or I don't have equal symbol. This is because it's separate.
Oh, God, yeah, on the graph.
So it's this one, because it's greater than or equal to, that will have the union always, no matter what. If it's the equal symbol, then the only difference is I will have a bracket. If there is no equal symbol, I have parentheses, and these are always parentheses. So the difference is whether it's in between or outside. Only the outside has the union. The in-between is already there. You don't have to, do not separate them. I saw some students, they separate them like this. For this one, they separate it. And they say they solve this inequality and then they solve this inequality, but then they forget, I saw that 1 second, but then they forget to intersect and they don't get the intersection. Yes, please. Yes, of course, yes. So let's do another union. So let's take a look at 78, which is the absolute value of 3 minus 3/4 x greater than 9. This is problem 78 on page 203. Very good. Okay, this is completely cleaned up. There is nothing we can do here. I'm going to cover it and just say and think and read this inequality. So I need to find numbers, these numbers, whose distance from 0 is more than 9. So I'm asking myself 2 questions. Is it in between or is it outside?
Outside.
It's outside. Which, when I say outside, then I have to write 2 separate inequalities, and the final solution will have the union in between. Yes.
3 minus 3/4 x greater than 9. And 3 minus 3/4 x is less than negative 9.
Now let's take a moment and see if this is clear. Is this clear to us? So more than 9 units means to the left, smaller than negative 9 or greater than positive 9. Is that clear, everyone? But now we have to solve both. So first, I'm going to subtract 3 from both sides. So I get negative 3/4 x greater than 6. I would like to remove what? I would like to remove negative 3/4 at once. What do I need to multiply both sides by? The multiplicative inverse or the reciprocal. Very good. Negative 4/3. negative 4 over 3. The left-hand side is exactly what I wanted it to be, which means exactly. And the right-hand side, always simplify before you multiply. It's not a mistake if you multiply and then simplify, but simplify first. 3 divided by 3 and 6 divided by 3. So it's negative 8. Now I have to think.
Now you flip the sign.
Yes. Why do I flip the sign? Because I multiplied both sides by negative 4/3. Perfect. Now I have to solve the other one. And I start by subtracting 3. Negative 3/4 x less than negative 12. I want to get rid of the same quantity, which is, very good, negative 4/3 and negative 4/3. Put parentheses to show that you are multiplying. The left-hand side is nice, which is, the right-hand side is simplify before you multiply. And the number must be positive. I simplify by 3. So I get, very good. Now I have to think. Very good. So now I have to write the union for the solution. Yes, indeed, I have to write this one first. Very good, awesome. Perfect. Well done. We feel a little bit better. We feel a little bit better. Okay, I'm looking for my document, the simplification by factoring. So let's take a look. I hope you have it with you. At the very end, we have 7 problems that I would like you to work on. And I will do 2 with you, and you do 5 at home between now and Tuesday, please. And I let you choose. It's the simplification by factoring document. So you'll do 5 and I'll do 2. And you choose. And after this we can start chapter 2, not 8. Any preferences? Simplification by factoring.
Number 6.
Okay. I don't want to waste their time. I was just looking for, yeah, here it is. I didn't get the chance to scan them just yet. Oh, you got 2. Is anyone missing? 1? You don't have it? You have it?
No, I never caught one. I wasn't here.
On the first day of class? You were not? Okay, I don't want to waste your time. As I said, I thought I found it, but this is my calculus class. It's not the other college algebra class, and I hope I didn't misplace it because I have to scan it. But it shows the exact same problem. It's so funny. Okay, number 6. Okay, good. So number 6, 2, x minus 4, 2x plus 7 cubed, minus x minus 4 squared times 3 times 2x plus 7 squared times 2. Everything divided by 2x plus 7 to the 6th. The requirement here is simplify by factoring. Okay. Here's my first question for you. Would you allow me to simplify 2x plus 7 cubed with 2x plus 7 to the 6th? Remove 3 from here and remove 3 from here. Is it a yes or is it a no? Absolutely not. Correct. Why? Because this is a factor and this is a part of a term. We cannot simplify terms with factors. So just make sure you don't do that. Second question for you. Let's look at the top and please tell me how many terms we have.
No.
How many terms we see at the top? Not factors.
4.
Okay, let me read it to you and then I'm hoping that you're going to come up with the correct answer. A product minus a product. So we have 2 terms. Exactly 2 terms. A product with several factors, another product with several factors, and they are subtracted. This is all one term till I get to a sum or a difference, and this is all one term because they're all multiplied. So terms are added or subtracted, but factors are always multiplied. Okay, so please remember the difference between terms and factors. Remember when we looked at the factoring document that I made, we said x cubed plus 2x, let's say, minus 4. How many terms we have here? 1, 2, 3, 4? No. We have, okay, blah, 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 plus, blah, 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 minus, blah, blah, blah. How many terms? Exactly 3. Till I get to a plus or a minus, that is only one term. One term, second term, third term. Good. So coming back here, would you say that this first term is pretty simplified? There is nothing I can rearrange. It's pretty much done. Okay, now let's look at the other one. I don't like a factor of 3 inside. I don't like a factor of 2 outside. I'm going to multiply these 2 and put it in front. What do I multiply? What do I get? And I'm going to put it in front. Correct. So I copy the first term. Put 6 in front. Okay. I go back now and look at these 2 terms and decide if they have anything in common. Before we do that, I would like to draw your attention to something that we've done in the past. If I have x to the 4th minus x squared, what do I factor out? Right, the smallest of the powers, correct. So I factor out x squared, the smallest that goes into both. Or I should say the largest that goes into both, and I have this, correct? The same idea we will be using right here, right now. Good. So I look at the first term and I look at the second term, and I see that they have what in common? 2 indeed. I look at the next, x minus 4. This one has power 1 and this one has power 2. Both have x minus 4 in common, but which power? 1, the smallest of the 2. Awesome. Perfect. Now I'm here and I look at this 2x plus 7 and 2x plus 7. They both have 2x plus 7. One has power 3, one has power 2. I have to choose 2x plus 7 to the... Very good. Awesome. Perfect. So now let's analyze in the next step and see what is left inside from each term. 2 is outside. Everything in x minus 4 is outside. Here, from these 3, I moved out in front 2 of those. So how many more are left? So I have to copy a 2x plus 7. Agreed? I reached the negative sign right now. Let's see what is left from the second term. From 6, I pulled out a 2, so there is a 3 left. From x minus 4 squared, I put an x minus 4 outside. What is left? In parentheses, an x minus 4. And let's see what is left from 2x plus 7. Well, nothing, because it had power 2 and I took all of them out. Are you with me, everyone?
Yeah.
Okay, now all I have to do is combine these. Also, would you allow me now to do this? Remove 2 factors of 2x plus 7 and remove 2 factors of 2x plus 7. 2 from the top and 2 from the bottom. Because I'm simplifying factors. This is multiplied by this, which is multiplied by this, which is multiplied by this. Everything is a factor. It's made out of factors. 1 factor, second factor, third factor, the fourth factor. I'm not simplifying terms. So I took away 2 from the top and 2 from the bottom. Agreed? So then the numerator is 2, x minus 4. Let's see what we have in parentheses. We have 2x plus 7 minus 3x and plus 12 over 2x plus 7 to the 4th power. That's why we are saying here, concerning this problem, we are saying simplify by factoring. So we factored first in order to be able to simplify it. Say it again.
Isn't the 4 change, this exchange to a 3?
Which one?
The 6th power?
I removed 2 from 2. And you have 6 and you give me 2.
Okay.
How many are left?
4. Okay.
Very good. So now I have to combine like terms inside parentheses. And this is it. So 2x minus 4. And this is minus x plus 19. And you have all the answers at the end of the handout. 2x plus at the bottom of that page. I don't like this, and I don't like what my department wrote, 19 minus x. I prefer factoring out the negative 1 from here. If I do factor a negative 1 from that factor, what do I get? In parentheses. What would you say? Very good. I prefer this. I accept this, and I accept 19 minus x.